Today's review video is on adding and subtracting of rational expressions. It's when you have different denominators. Everybody seems to be okay when the denominators are the same, but it's when we have unlike denominators, people tend to make many mistakes. Whenever you're adding and subtracting rational expressions, it's like adding and subtracting fractions. You follow the exact same rules. You have to have a common denominator in order to add or subtract. Once you find a common denominator, you bring over the denominator, you add or subtract the numerators, and then at the end you see if you can actually reduce. And in our case it would be factor and cancel. All right, well, let's take a look at this example number 3 and see what we can do here. Definitely don't have common denominators, though they look very similar. So I'm thinking a little bit in my thought process. Isn't it true that if I have a subtraction binomial and they're in opposite order and they're written as a fraction, they reduce to be a -1? Which tells me if I multiply one of them through by a -1, they're going to look the same. So what I'm going to do is I'm going to multiply the second denominator by a -1, which I'll have to do distributive property. But again, the rule is in fractions, whatever you do to the bottom, you have to do to the top. Okay, so I'm going to rewrite my fractions now and see what happens. I didn't do anything to the first fraction. Whoops, let me erase that a little bit. Plus, I get a -8 on the top, and if I multiply out the bottom, I get a -4 plus x, which is x minus 4. I've got a common denominator. So what I'm going to do now is bring over the denominator, because they're common. I'm going to add the numerator, so I get 2x minus 8. That's my answer. But now I have to say, can I simplify that answer? Can it be reduced? Well, the numerator I can GCF out of 2. Can't do anything to the denominator. Oh, look it. I can cancel this binomial for this binomial. There's nothing left on the bottom. It's 1. There's a 2 left on the top. I don't need the 1 when it's on the bottom. So my answer is 2. That one wasn't too bad. Let's go to the next one here. This one's a little different, okay? Because basically they don't look the same where they're in opposite order or anything. So when you've got two binomials that look completely different, what you want to do is make sure the denominators are factored. All right, I can't do anything to x minus 3, but x squared minus 9 is dot, so it's x minus 3 times x plus 3. Now I can see this a little bit more clearly, so I'm going to cross that out because I just rewrote it. So if I want a common denominator, all I would have to do is give the first fraction x plus 3 and I'd have a common denominator. So that's what I'm going to do. For the common denominator, I'm going to use x minus 3 times x plus 3. Now, what did I give the first fraction to make him look like this new denominator? You're right, I multiplied the bottom by x plus 3. So I have to multiply the whole top by x plus 3, which is going to give me distributive property x squared plus 3x. You actually have to multiply it out, okay? What did I give the second fraction to make him look like this? Nothing. He stayed exactly the same, so the numerator is going to stay exactly the same. All right, I've got a common denominator, so I'm going to bring it over. I'm going to subtract numerators. X squared, no squarings to subtract with him, bring him down. A positive 3x, no x's to put with him, bring him down. Nothing minus 18 is a -18. There's my answer. Now I have to take a look and see if I can actually factor to see if anything will cancel. So I bring over the denominator again. It's already factored. I'm going to go to two binomials. Let's see, it's an x and an x. I need factors of a -18 that'll give me a positive 3. Plus 6 and minus 3. Oh, in this case I can actually cancel out the x minus 3's. And my final answer is x plus 6 over x plus 3. That one wasn't too bad either. All right, let's do another one. All right, with number 5, I don't have common denominators. I really can't factor either of them. They really have nothing the same. So I'm going to have to use both of them. So what I'm going to use for a common denominator is x times x plus 1. Alright, what did I multiply the first denominator by to make him look like the new one? I multiplied him by an x, so I got to multiply the top by an x, and I'll get 3x. What did I multiply the second denominator by? I multiplied him by x plus 1, so I'm going to have to multiply him by x plus 1, and I'm going to end up with 2x plus 2, distributive property. Okay, I have a common denominator, so I'm going to bring it over. I'm going to subtract the numerators. 3x minus 2x is an x. Nothing minus 2 is a minus 2 because you have to keep jumping to the middle. X minus 2 can't be reduced. And x times x plus 1 is already reduced. I don't have anything in common. So basically, that's my answer. All right, let's do one more. Again, I don't have a common denominator, and I'm not really sure what to use, so I'm going to factor those guys out to see what I got here. This guy looks like it would factor out to x plus 2 times x plus 1. So all I did was rewrite him. This guy looks like he's dots x plus 1 times x plus 2. Whoops, my mistake. X plus 1 times x minus 1. Alright, well let's see. They both have an x plus 1, so if I give the right side an x plus 2 and the left side an x minus 1, they'd have a common denominator. So that's what I'm going to use. So this one's going to be a pretty big one. Alright, so here we go. Let's set this up. So my common denominator is going to be x plus 2 times x plus 1 times x minus 1. Alright, what did I give the first denominator to make him look like the new one? I gave him an x minus 1. So I multiplied him by x minus 1. So I got to multiply the top by x minus 1. And I'm going to get 1 times x minus 1 is x minus 1. What did I give the second guy here? I gave him an x plus 2, where I multiplied him by x plus 2. So I'm going to have to multiply this guy by x plus 2. And I'll end up with 2x plus 4. I'm adding, which makes it nice. So I've got a common denominator. I'm going to bring it down. X plus 2x is 3x. A negative 1 plus 4 is a negative, or is a positive 3. All right, now I'm going to see if I can factor. The top I can GCF out of 3 and get x plus 1. The bottom is already factored. Bring them over. I can cancel out the x plus 1s. So my final answer is going to be 3 over x plus 2 times x minus 1. And there's my answer. I hope this cleared up a lot of questions you had on adding and subtracting rational expressions with unlike denominators. Feel free to review the video as many times as you would like.